Welcome to Chapter 18, the Hierarchy of Intersection Control, and today is the part 2 of the lecture. As we discussed in the previous lecture, we talked about level 1 control, which is the basic rules of the road, and also level 2 control, which is yield and stop sign controls. And now we will be talking about the level 3, which is the highest level of how we, as a traffic engineers, control the intersection, is basically by having a traffic signals. As I mentioned, the ultimate form of intersection control is really the traffic signal compared to the previous two levels of the rules of the road as level 1 and yield or stop sign as level 2. Now it's more sophisticated intersections, we tend to use traffic signals. Traffic signals has lots of advantages if they are designed very well. The MUTCD manual shows that there are at least 5 advantages. The first advantage is really traffic signals would tend to provide for the orderly movement of traffic, so it would make the traffic movements very regular and in order. The second advantage is traffic signals would tend also to increase the traffic handling capacity of the intersection only if proper physical layouts and control measurements are used and if the signal timing is reviewed and updated on a regular basis. Typically that update would happen every 2 years in order to assure that it really satisfies the current traffic demands. The third advantage of having a traffic signal is that they reduce the frequency and severity of certain types of crashes. Traffic signals, if they are designed well in the right location, they would tend to reduce the amount of crashes, especially the right angle collisions. Another advantage also for having a traffic signal that they are coordinated to provide for continuous or nearly continuous movement at a definite speed along a given route under favorable conditions. And one of the assumptions that we always make here while we're designing the traffic signals and the lighting is if you are on the right speed limit, you would be able to go through most of the intersections with the green light. The fifth advantage of having a traffic signal is that they are used to interrupt heavy traffic at intervals in order to permit other traffic, vehicular or pedestrians to cross. Mainly that happens during the intersection of a major road versus a minor road, and if we're not having a traffic signal, we're not going to really give a chance to the vehicles on the minor road to turn right or left to join the traffic in the major road. On the other side, if we're having poor design of either signalization or the geometry of the intersection, this can significantly reduce the benefits of having traffic signals. In fact, it even can refute its location entirely. So if we're having improper traffic signals or it's placed wrongly, it can have the following disadvantages. The very first disadvantage of having a poorly designed traffic signal is going to cause excessive delay, and therefore the second disadvantage is basically as a result of this first one. People now are going to be irritated, and because of what they are having too much delay, and therefore we're going to experience excessive disobedience of the signal incidents and indications. Also, another advantage is we can observe an increased use of less adequate routes as road users to try to attempt to avoid the traffic control signal, as well as we may also see significant increase in the frequency of collision, especially the rear end collisions. So again, we need to balance and we need to have the right design to obtain the advantages of a traffic signal and try to avoid the disadvantages of having a traffic signal. So to have a traffic signal at a certain location, there are different 9 warrants or 9 specifications or 9 conditions that the MUTCD define, and if we are at least meeting one of these 9, we can add a traffic signal at this location. The MUTCD manual requires, however, that a comprehensive engineering study must be conducted in order to determine whether or not installation of a signal at certain location is really justified. That study has to be including applicable factors reflected in the specified warrants, but also it could be extended to other factors as well, depending on the case. However, traffic signals control should be implemented if none of the warrants are met. So we cannot really just implement the traffic signal if we're not meeting any of the 9 warrants. The warrants, therefore, still require the exercise of engineering judgment, but in the final analysis, basically, if engineering studies or judgment indicate that signal installation will not improve the overall safety or operational efficiency at a candidate location, it shouldn't be installed. So what are these 9 warrants? So we will be talking about the 9 warrants, and before going to the 9 warrants, there are several things that need to be collected during the engineering study of the need of a traffic signal. The very first thing that you need to capture is really the number of vehicles entering the intersection from each approach during 12 hours of an average day. So how will you pick those 12 hours? It is really desirable that the 12 hours selected contain the greatest percentage of the 24-hour traffic volume. You also need, while you are doing this engineering study, to have the vehicular volumes for each traffic movement, also for each approach, as well as classified by vehicle type. So we need to know how many heavy trucks do you observe, passenger cars, light trucks, public transit vehicles, and in some locations even bicycles. And those information need to be collected during each 15-minute period of the 2 hours in the morning and 2 hours in the afternoon, during which the total traffic entering the intersection is the greatest. You also have to collect information about pedestrians, so we need to know pedestrian volume counts on each crosswalk during the same periods as the vehicular counts in item 2 above and during hours of highest pedestrian volume. Another bullet here that we need to have included in our engineering study is any information about nearby facilities and activity centers that they may serve young, elderly, and persons with disabilities during the requests from persons with disabilities for accessible parking improvements at the location under study. So we need to have this in mind as well. There's 3 more things here that we need to collect at any engineering study before we place a traffic signal. Number 6 is we need to know what's the posted speed limit or the 85th percentile speed on the uncontrolled approaches of the location. Besides this, we need to collect also the condition diagram as well as collision diagram. Condition diagram, it should show details on the physical layout, including features such as intersection geometrics, also if we have any channelization, any grades, sight distance restrictions, transit stops and routes, even all the way to parking conditions. While collision diagram should be showing crash experience, and that crash or accident experience, it has to be classified by type, location, direction of the movement, severity, weather, time of the day, the date, and even what was the day of the week for at least 1 year. The MUTCD also require, on top of all this, also require and recommends the collection of a stop time delay data and queuing information at some locations where these are believed to be problems. So what are these warrants? The warrants for traffic signals, based on the collected data, will allow the engineer to fully evaluate whether or not the intersection satisfies the requirements of one or more of the following warrants. Warrant 1 is 8-hour vehicular volume, warrant 2 4-hour vehicular volume, warrant 3 peak hour, warrant 4 pedestrian volume, warrant 5 school crossing, warrant 6 coordinated signal system, warrant 7 is crash experience, warrant 8 roadway network, all the way to the last warrant, which was added recently, and this is the intersection, if the intersection is near a highway rail crossing. So warrant 1, it has to do with the 8-hour vehicular volume. It really try to address the need for signalization for conditions that exist over an extended periods of the day, and that extended period of the day a minimum of 8 hours. 2 of the most fundamental reasons for signalizing has to be addressed under this warrant. The very first case, or condition A, this is in the case if we are having heavy volumes on conflicting cross movement that make it impractical for drivers to select gaps in an uninterrupted traffic stream through which to safely pass. In fact, this requirement is often referred to the minimum vehicular volume condition, and it's referred as condition A, as we're going to see in the next slide in the table. Condition B under warrant 1 has to do with the vehicular volume on the major street are so heavy that no minor street vehicle can safely pass through the major street traffic stream without the aid of signals. This requirement is typically referred to as the interruption of continuous traffic. So the question here, how can we meet this warrant? Since we have condition A and condition B as shown in table 18.5, here we have condition A and condition B. So the warrant is really met first if either condition A or B are met at 100% level, or the second case if either condition A or B is met at 70% level, where the intersection is located as an isolated community of population 10,000 or less, or where the major street approach speed is 40 miles per hour or higher. The third case, if both conditions A and B are met at 80%, this is also, we would consider warrant 1 is met, and therefore we can have a traffic signal based on warrant 1. So how can we use this table right here? So let's assume we're having two, as you could see here, the first column is the number of lanes for moving traffic on each approach. We're having the number of lanes for the major streets and the number of lanes for the minor streets. So you need to know the geometry of the intersection first, and then you will go here and see basically what are the vehicle per hour on major street and the vehicles per hour on higher volume minor street approach. So this is here, this is the total in both directions, and this is in one direction. So for example, let's say I have 2 lanes or more in major street and one lane in the minor street. So we need to know the amount of vehicles on both. So for example, 2 or more lanes in the major street, let's say they have 500 vehicles, and the minor street have 150 vehicles. So we will go to 2 or more, and we're having 1, which is the second case. And again, let's say I have 500, so the 500 here is gonna be somewhere between 80% and 10% and 100%, while if I have traffic at the vehicles or the traffic in the minor street is about 100, this means this is here 105 is the minimum for 70. So this is now, we can say that this for this condition is 70%. So we need to be aware that there are 2 numbers has to be met, and we would pick the lowest one. For example, again, let's see here for the major street. For the major street I have 2 lanes, and one more time again I have 500 vehicles. This is the summation in the 2 directions. And for the minor street, I have 1 lane, and let's say I have 150 vehicles. So the way I would do, again, I would pick this line, and now the 500, which is the total vehicles per hour on a major street, is somewhere between these 2 numbers, 480 and 600. So when it comes to the major street, it's 80%. It's satisfying the 80%, but it doesn't reach the 100%. When it comes to the minor, it's 150. So 150 would be here. So that would be 150. So it's 100% for the minor, but it's 80% for the major, and therefore we say this warrant was met at 80%. Same thing now for the condition B, which is interruption of continuous traffic. Let's try now to apply the same concept here. If we have a major street, 2 or more, and 1, which is gonna be this one here, second line, and now I'm gonna say the 500 is even less than 70%, and the 150 is way higher. So for the minor road is 100%, but for the major road is less than 70%, and therefore we are meeting the condition at 70%. Okay, how about now warrant 2? Warrant 2 is related to the 4-hour vehicular volume. This warrant was introduced in the 1970s, really in order to assist in the evaluation of situations where volume levels requiring signal control might exist for periods shorter than 8 hours. So in order to test this warrant, we need to have the two-way major street volume need to be plotted against the highest one-way volume on the minor street for each hour of the study period. And in order to meet the warrant, at least 4 hours must plot above the appropriate decision curve. So here we're having curves here. Each curve, it has its own the geometry of the intersection. For example, the very lower line here represents 1 lane for the major, 1 lane for the minor. Second line is 2 lanes or more for the major, 1 lane for the minor, and the highest line would be 2 or more lanes in the major, 2 or more lanes in the minor. And I would need to plot all the 12 points collected from the engineering study, and if I have 4 points out of those 12 above the appropriate decision curve, then that means I am meeting this warrant. And the next question would be, what's the difference between this figure and this figure? They're pretty much the same, but the A figure, this figure here, it's for the normal conditions, while B figure is for populations less than 10,000 people. So this is for little towns and cities that they have less than 10,000 people. How about warrant 3? Warrant 3, it has to do with the peak hour. It really addresses 2 critical situations that might exist for only 1 hour of the typical day. So these 2 situations, the first is the volume condition, which is similar to warrant 2, and the second is the delay warrant. So how can we meet this criteria or warrant? If either condition is satisfied, the peak hour warrant is met, and the volume portion of the warrant is implemented in the same manner actually as the 4-hour warrant. For each hour of the study, the two-way major street volume is plotted against the high single direction volume of the minor street, and for the peak hour volume warrant, however, only 1 hour must plot above the appropriate decision line in order to meet that criteria. So this is here condition A, and this condition B related to the delay. So for condition A, under this warrant, I will plot all the 12 points, and 1 point only, if 1 point only is higher than the appropriate decision curve, this means the warrant is met. The other part of warrant 3, which is 3B, this is has to do with the delay, and basically the MUTCD says the need for a traffic control signal shall be considered if an engineering study finds that all 3 of the following conditions exist for the same 1 hour. Any 4 consecutive, and that 1 hour defined as any 4 consecutive 15 minutes periods on an average day. So we can guarantee this warrant by if we have the total stop time delay experienced by traffic on one minor street approach controlled by a stop sign equals or exceed 4 vehicle hours for 1 lane approach, or 5 vehicle hours for a 2-lane approach, and the volume on the same minor street approach equals or exceed 100 vehicles per hour for 1 moving lane of traffic, or 150 vehicles per hour for 2 moving lanes, and the total entering volume serviced during the hour equals or exceeds 650 vehicles per hour for intersection with 3 approaches, or 800 vehicles per hour for intersections with 4 or more approaches. So if you can satisfy warrant 3B but you're not satisfying warrant 3A, still warrant 3 would govern, and therefore we can place a traffic signal based on warrant 3. The 4th warrant has to do with pedestrians. This warrant really tries to address situations in which the need for signalization is the frequency of vehicle-pedestrian conflicts, and sometimes even the inability for pedestrians to avoid such conflicts due to the volume of traffic. So for this case, signals may be placed under this warrant at mid-block locations as well as the intersection. And the question now would be, how are we going to meet this warrant? This warrant is met when any 4 hourly plots of total pedestrian crossing the major street and the total major street vehicular traffic falls over the line in figure 18.7a, or when any one similar hourly plot falls above the line in figure 18.8a. We're gonna see the figures in a second, but if the location is in a small community, then we're gonna use figures 18.7b and 18.8b. So here are the figures 18.7 and 18.8. So the y-axis, as you could see, this is the total number of pedestrians crossing the major street, and the x-axis is the major street total volumes in vehicles per hour. So if we plot all the 12 points and at least 4 of them above this line, then we're meeting the specs. Or if we plot all the 12 points on this figure here and we just have one of them is above the curve, that would be enough to meet the criteria. 18.7b and 18.8b, those are the same x and y axes, but those for smaller populations and small towns that has people less than 10,000 people. Warrant 5 is school crossing. So this warrant is very similar to the pedestrian warrant, but in this case is very limited to the application at a designated school crossing location, either at intersections or at mid-block location. So this warrant really requires the study of available gaps in order to see whether they are acceptable for children to cross through. So that acceptable gap would include the crossing time, the buffer time, and also an allowance for groups of children to start crossing the street. The minimum number of children crossing the major street typically is about 20 during the highest crossing hour. But one of the things here when it comes to that warrant, school crossing, traffic signals are rarely implemented under this warrant. Why? Because children do not usually observe and obey signals regularly, particularly if they are very young. So if we are having this issue, lots of kids are crossing the street, and we need to improve the situation. We can improve the situation by having crossing guards in most cases, while if it's more extreme case, we're having higher volumes of school children crossing a very wide and heavily traveled major street, then we're going to go to the other level of separating pedestrians from cars, and that can be done by having an overpasses or underpasses that they have to be provided with barriers in order to prevent entry onto the street. Warrant 6 is a coordinated signal system. Basically this warrant talks about the distances between two adjacent signals. So if the distance between two adjacent coordinated signals is too large, then platoons or the regular traffic or the regular traffic movement begins to dissipate, and the positive impact of the progression is sharply reduced. In such cases, the traffic engineer may replace a signal at an intermediate intersection where it wouldn't otherwise be warranted to reinforce the coordination scheme and to help maintain platoon coherence. So we can also look at this table here, table 18.7, which is from the MUTCD for warrant 6. So let's just read here and see what does it really talk about. So the need for a traffic control signal shall be considered if an engineering study finds that one of the following criteria is met. So the first criteria to meet level 3 warrant 6 is on a one-way street or a street that has traffic predominantly in one direction, the adjacent traffic control signals are so far apart that they do not provide a necessary degree of vehicular platooning. Or on a two-way street, adjacent traffic control signals do not provide the necessary degree of platooning, and the proposed and adjacent traffic control signal will collectively provide a progressive operation. So that's basically warrant 6. Warrant 7, it has to do with crash experience. So this warrant tries to address cases in which a traffic control signal would be installed to alleviate an observed high accident occurrence at the intersection. Not any accident can be improved or can be reduced by having a signal. Those accidents that are susceptible to correction by signalization include right-angle accidents, accidents involving turning vehicles from the two streets, and accidents between vehicles and pedestrians crossing the street on which the vehicle is traveling. Table 18.8, this is also from METCD, talks about the crash experience and what are the numbers to consider. This place are having too much of car crashes, and therefore we have to have a traffic control signal. So I'm gonna read off this table here. The need for a traffic control signal shall be considered if an engineering study finds that all of the following criteria are met. So now we have to follow these three criteria to have warrant 7 as a meeting warrant for having a signal. The first condition is we're having adequate trial of alternatives with satisfactory observance and enforcement has failed to reduce the crash frequency. So basically here we're saying we tried to fix the problem of having accidents by level 1 and 2, it still didn't work. And number 2, if we're observing 5 or more reported crashes of types susceptible to correction by a traffic control signal have occurred within a 12-month period, each involving an personal injury or property damage apparently exceeding the applicable requirements for a reportable crash. And the third condition is for each of any 8 hours of the day, vehicles per hour, which is VPH, vehicles per hour, given in both of the 80% conditions of condition A in warrant 1, or the vehicles per hour in both of the 80% columns of condition B in warrant 1 exist on the major street and the higher volume minor street approach, respectively, to the intersection, or the volume pedestrian traffic is not less than 80% of the requirement specified in pedestrian volume warrant. These major streets and minor street volumes shall be for the same 8 hours. On the minor street, though, the higher volume shall not be required to be on the same approach during each of the 8 hours. So basically, again, once we start observing certain amount of accidents reported for this location, and we tried with different types of controlling rather than traffic control, if everything is failing, then we have to go to level 3 and have to have a traffic control signal for this intersection that is really experiencing more than average amount of crashes and accidents. Warrant 8, this has to do with the roadway network. This warrant addresses a developing situation. For example, a case in which present volumes wouldn't justify signalization, but I'm expecting to have a new development generated at this location, and therefore is going to generate substantial traffic that would justify signalization in the near future. So the MUTCD in this case allows other warrants to be applied based on properly forecast vehicular and pedestrian volumes. I may not experience that much of a traffic now, but if I have a very near future prediction of increased traffic volumes and pedestrians, this is the warrant that I need to use. For large traffic generators such as regional shopping centers, sports stadiums, arenas, small facilities are often built in areas that are sparsely populated and where existing roadways have light traffic. And those are the location, again, I need to justify that in the near future, once I have an opening for a big shopping center in this location, I'm expecting to have lots of traffic volumes and pedestrian interactions as well, and therefore I may need to have traffic signal based on the near future prediction. So table 18.9, this is warrant 8, roadway network, and basically here it says the need for a traffic control signal shall be considered if an engineering study finds that the common intersection of two or more major routes meet one or both of the following criteria. So it's at least one of the two criteria. First is if the intersection has a total existing or immediately projected entering volume of at least 1,000 vehicles per hour during the peak hour of a typical weekday, and has 5-year projected traffic volumes based upon an engineering study that meet one or more of warrants 1, 2, or 3 during the average weekday. Or I can meet the warrant 8 if the intersection has a total existing of immediately projected entering volume of at least 1,000 vehicles per hour for each of any 5 hours of a non-normal business day, which is a Saturday or a Sunday. When it comes to a major route are used in this warrant shall have one or more of the following characteristics. At least the major route has to be a part of the street or highway system that serves as the principal roadway network for a through traffic flow, or this major route has to include a rural or suburban highways outside entering or traversing a city, or this major route has to appear as a major route on an official plan such as a major street plan in an urban area traffic and transportation study. Warrant 9, which is the last one, is the intersection. If the intersection is near a highway rail road crossing. This is the newest warrant that was added in the updated MUTCD 2010, and it really addresses a unique situation. The situation is basically if an intersection that does not meet any of the other warrants for signalization, but it is close enough to a highway railroad crossing that can present a hazardous situation. So table 18.10 talks about this warrant, which is shows the need. The need for a traffic control signal shall be considered if an engineering study finds that both of the following criteria are met. So we need to be careful. Some of the criteria, both conditions or more than two conditions, has to be met. In other cases, at least one has to be met. Here, both situations has to be met. What are these two situations? The first one is if the highway and rail grade crossing exits on approach controlled by a stop or yield sign, and the center of the track nearest to the intersection is within 140 feet of the stop line on the approach, and during the highest traffic volume hour during which trains use the crossing, the plotted point representing the vehicles per hour on the major street, which is total of both approaches, and the corresponding vehicles per hour on the minor street approach that crosses the track, falls above the applicable curve in figures 18.9 or 18.10 for existing combination of approach lanes over the track and distance D, which is the clear storage distance between the grade crossing stop line and the near curb line of the major street. So to put this into an easier way to understand, let's take a look at the next figure. So this figure here is for major streets, and basically what I need to know to get to this figure and to see if I'm meeting the criteria or I'm meeting warrant 9, I need to know the x-axis value, which is the major street total of both approaches, which is vehicles per hour, and the y-axis now is the minor street crossing approach equivalent for vehicles per hour. So which line you can pick, it really depends on how close are you to the railroad. So the D, this is the D that you need to know. This is the distance from the intersection of the major street and minor street. So the distance in the minor street until I reach the railroad, that will be the D. So I have D from 30 feet, which is 9 meters, all the way if I have 130 feet, which is 40 meters. And if you have 1 point above the predicted line, then you are meeting the specs. This is here again another figure, which is figure 2. This is here for 25 vehicles per hour applies at the lower threshold volume. And we also have other correction factors. So before we get to these two the previous two figures, we need to do some adjustments. The previous two figures were done with certain assumptions. The first assumption is if I have trains per day equal to 3 to 5. If I have trains 3 to 5, then the correction is 1. That correction, basically, this is the minor street volume that need to be adjusted, and that's what I have here. The minor street volume need to be adjusted using tables 18.11, 12, and 13. So for example, if I tell you that I had 9 to 11 trains per day, this means the adjustment factor now is going to be 1.25 times the minor street volume before I get to the previous two figures. Also 18.12, it has to do with the high occupancy buses. The previous two figures are built on I have 0% of high occupancy vehicles or buses. So if I have buses that has high occupancy, let's say 4%, is the correction factor of the minor street volume is need to be multiplied by 1.19. The third correction has to do with the tractor trailer trucks. The assumption was done for 7.6 to 12.5%. This is the default value for the percentage of tractor trailers. If I have more than this, for example, if I have more than 27%, 0.5 of the traffic is tractor trailers, then I have to multiply I have to multiply the volumes of the minor street by the correction factor. Depends on if the D is less than 70, this is the correction factor is going to be 4.18. If the D is 70 feet or more, then the correction factor is going to be 2.09. So let's start with an example now, so we can make sure we're grasping all the warrants, the 9 warrants, and how can we use an engineering study information to decide for us if this intersection right here need the signalization or not. So this is here the information based on the engineering study. So it was done for 12 hours as we discussed before. So we would always pick the highest 12 hours out of the 24, and here it happened to be from 11 a.m. to 11 p.m. So the information here was provided for both the main street volume as well as the minor street volume here, which is called First Avenue volume. And also we've been provided with the pedestrian volume, which we're going to need to decide on warrant number 3. So as you could see, the eastbound and the westbound, and we're really interested now in the total. As we mentioned in all the warrants, we're interested in the total amount of volumes in both major street and the minor street, and that's why we're going to end up using those two numbers besides the crossing, the pedestrian volume crossing, and those will be plotted in several figures to decide whether or not we're meeting that certain criteria or certain warrant. Besides the volumes that we see here, that we need to spend about, again, 12 hours in the field, we also have some information related to the delay as well as the annual accidents. The delay is going to be used in one of the criteria, as we're going to see in a little bit, which I think it's warrant 3. So we're saying the delay every vehicle, or the delay in general, we're having 30 seconds per vehicle. So the delay, every vehicle is experiencing 30 seconds of delay. Also, there is information related to the crash experience or the accidents, because this is also going to be used in warrant 7. So we're having annual accidents. We have 4 right angle with injuries, 3 left turn with injuries, 5 rear end with personal damage occurred, and 3 pedestrian with 1 fatality. So let's start with the first one. So warrant 1, if you go back to the warrant 1, we had this table with condition A and B, you would notice that there is no indication that the 70% reduction factor applies. So it is assumed that either condition A or condition B must be met at 100%, or both must be met at 80%. So there is no indication again for the middle case, where we have small community or speed less more than 40 miles per hour. So to meet condition A requires 600 vehicles in both directions on the multi-lane major street and 150 vehicles in the high volume direction on the one lane minor street. So if you go again to the table, you would see although all 12 hours on the major street shown in figure 18.11 have more than 600 vehicles per hour, none has a one-way volume equal or higher than 150 vehicles per hour on the minor street. Therefore, condition A is not met. Condition B requires 900 vehicles per hour on the major street and 75 vehicles per hour on the minor street. And the 10 hours between 12 noon and 10 p.m. meet the major street criteria. The same 10 hours meet the minor street criteria as well, and therefore condition B now is met. Because one condition is met at 100%, the consideration of whether both conditions are met at 80% is not necessary, and warrant 1 is satisfied by condition 1, which is if I'm meeting one of the two conditions at 100%, the warrant is satisfied. So I need a traffic signal based on level 1 or based on warrant 1. Let's go and see now other warrants and if they are met or not. Warrant 2, now we need to use figure 18.12. Figure 18.12, if you plot all the points, the total points, total volumes in the major versus the minor, and figure 18.12 would show the hourly volume data plotted against the 4-hour warrant graph. The center decision curve, which is this one here, because we have one street with multi-lane approaches and the minor street has one lane approach. So this is the line that we need to follow. And as you could see, we have only 1 point of the 12 hours is above the criterion. And to meet the warrant, we have to have 4 are required. Therefore, the warrant is not met. So far we have warrant 1 was met, but warrant 2 is not met. How about warrant 3? Warrant 3 now we're going to be using figure 18.13 that shows the hourly volume data plotted against the peak hour volume warrant graph. Again, the center decision curve would be used because we're having 2 or more lanes in the major street and 1 only lane on the minor street. So as you could see, none of the 12, now all of them you see beneath the criteria curve, and therefore none of the 12 hours of the data is above the criteria. The volume portion of this warrant is not met. The delay portion, because you may ask, how about the delay portion? The delay portion of the peak hour warrant requires 4 vehicle hour of delay in the high volume direction on a stop control approach. The intersection data indicates that each vehicle experiences 30 seconds of delay. Therefore, the peak one direction volume is 125 vehicles per hour, resulting in 125 times 30 seconds. So that's going to give us 3,750 vehicle seconds of aggregate delay, or you can divide this by 3,600 seconds to know how many hours, and that would be 1.04 vehicles per hour of delay, which is less than the required by the warrant, and therefore the delay portion of this warrant is not met as well. So warrant 3, based on the volumes, is not met, and based on the delay amount, it was just 1.04, way less than the requirement, and therefore the entire warrant 3 is not met. How about warrant 4? Warrant 4, this warrant includes both the 4-hour criteria and the peak hour criterion, only one of which must be met to satisfy it. So if you go to figure 18.14, illustrate the solution. So here, this is we need to have 4 out of the 12, and as you could see, the 4-hour pedestrian warrant is met because we're having 4, but the peak hour pedestrian warrant is not met because only one condition must be satisfied, then the pedestrian warrant is met. So pedestrian warrant, as we remember, we have 2 graphs, one for 4 hours. If we have 4 hours and above the line, this is going to be met, or if we can use this portion here, this is if we need to have at least 1 point above. So if we satisfy one of them, which we did here, then warrant 4 is also met. So now we have warrant 1 is met, 2 and 3 are not met, and warrant 4 is met. Now the rest of the warrants, which are pretty much special cases, warrant 5 has to do with the school. So the school crossing warrants doesn't apply, so this is not a school crossing, or at least it wasn't mentioned in this problem. Warrant 6 also, there was no information on signal progression is given, so this warrant cannot be applied. Warrant 7, the crash experience warrant has several criteria. We have to have lesser measures been tried. If the answer is yes, because the minor street is already a stop controlled. So we have to have 5 accidents susceptible to correction by signalization occurred in the 12 months period. If the answer is yes, then 4 right angle, 3 left turn, and 3 pedestrian are the criteria for warrant 1A or 1B met to the extent of 80%. If the answer is yes, then warrant 1B is met at 100%, therefore the crash experience warrant is met. Warrant 8, there is no information given concerning if there is a roadway network and the data reflect an existing situation, therefore this warrant is not really applicable in this case, as well as warrant 9, because the situation here is we're far away from a railroad crossing, therefore the warrant is not applicable. So again, one more time here, I want to point out that warrant 7 has to do with the number of accidents that were reported. If you go back to the previous slide that shows how many accidents and the type of accidents, that's why here we're having yes, because the question for warrant 7, do we have 5 accidents susceptible to correction by signalization in 12 hours? The answer is yes, because we had more than that, because we had 4 right angle and 3 left 4 right angle and 3 left turn and 3 pedestrian, so those are total of 4 plus 3 plus 3, and that's gonna be 10, so it's way higher than the 5. And also we have to meet the second portion of warrant 7, which is are the criteria for warrant 1A and or 1B is met, and the answer was yes, and therefore the entire warrant 7 is met as well. So what do we conclude from this example? In summary, a signal at this location should be considered because the criteria for warrants 1B, number 4, and number 7 are all met, and therefore I need to have a traffic signal at this location. With this example, we finished chapter 18. Thank you so much.